Hi and welcome. We wanted to have a review section where we talked about trigonometry and especially right triangles because there are a lot of those in physics when we start doing vector analysis. So I wanted to start out talking about just triangles generally, and then we'll get into some more specific stuff that is going to be helpful when we get into Unit 1 on momentum and some of the others as well. So if we have a right triangle, which you recognize because it has a right angle in the corner, we usually put a little square in that corner to show us that it's a square angle. For most of the trig that we do, you have to identify yourself with one of the corners. There'll be one angle that you know, and you imagine yourself standing in that corner. And we're going to label the triangle based on that position. So if you're standing there, first of all, the longest side of that triangle, the one across from the right angle, is the one we call the hypotenuse. Fairly easy to spot. And the other side that's right beside you, where you're standing, we call the adjacent side. Adjacent means beside. And the third side, the one that's across the triangle from you, we call the opposite side. It's the one that you would have to go for a walk if you wanted to touch it. You can't reach it from where you are. So that's how we label the three sides. Now, if you change positions, or if you think of another person standing up in this corner, this person would agree with you about the hypotenuse. They would say, just like you, that this is the longest side and that it's across from the right angle. Nothing about that has anything to do with your position, so no problem there. But this person would say that this is their adjacent side. And this green person would say that this is their opposite side. So you have to make it clear which of these people you are, because that's going to determine what trig functions we use. So about that, this SOHCAHTOA mnemonic that we use to help us remember the trig functions, here's what it actually means. It says that the sine of an angle is O over H is opposite over hypotenuse. CAH says that the cosine of an angle, we use the Greek letter theta to stand for an angle often when we don't know what it is. Cosine is AH adjacent over hypotenuse. And TOA tells us that the tangent of an angle, tan theta, is OA opposite over adjacent. So for any pair of sides that you want to work with, there's one trig function that can help you, one that uses the two sides that you are interested in. So let's do a couple examples of that just to see how that's going to work. We can keep this triangle. Oh, no, we can't. We can't because I'm not slick enough with the eraser, so new triangle. So if we have a triangle that's, let's say, 13 and 12 and 5, and this angle I believe is 22.6 degrees. There are three things we could write if we're standing in this position. If they asked for the sine of 22.6 degrees, sine 22.6, that would be opposite over hypotenuse. So sine 22.6 should be the opposite side, which is 5, over the hypotenuse, which is 13. If they asked you for the cosine of 22.6, cosine is adjacent over hypotenuse, so for us that would be 12 over 13, adjacent side over hypotenuse. And finally, if they asked you for the tangent of that angle, tangent is opposite over adjacent, so 5 over 12. Now, this isn't a very realistic type of problem because in this triangle, we already knew the angle and all three sides. We're rarely that lucky. So I hope you got this. This was just to reinforce what the opposite and adjacent and hypotenuse are and what these trig expressions generally look like. But let's do a little more realistic one where we don't know everything, and that should be a little more rewarding. So there is a tree. And there is you. And you want to know how tall the tree is. You can't climb it to measure it because it's all needly and you don't want to cut it down. But you want to find this height somehow. What you can do is start at the tree and walk up a certain distance. Let's say you step 15 meters back, and then you measure the angle to the top of the tree, and you find that it's, let's say it's 62 degrees. How could we find the height of the tree? One of these trig functions can help. We know the adjacent side of this triangle, and we want to find the opposite side of this triangle, and we kind of don't care about the hypotenuse. The hypotenuse is how far it is from us to the tip of the tree, and that's not really part of the question. So adjacent and opposite are the ones that we'd really like to use, and tangent ties those together. We can write a tan expression for this, and it will look like tan 62. Where can I put this? The tangent of 62 degrees equals the opposite side, which I'm calling h. This h is not for hypotenuse, it's for height. That's a little awkward, but it happens fairly often. And the adjacent side is 15. All right, so this is the tangent of our angle equals opposite over adjacent. Now we can solve this because our calculator can tell us what tan 62 is. On some of them you have to put 62 and then hit tan. On Texas Instruments calculators it's probably you hit tan and then put in 62 and then enter. And when I do that I get 1.88. So this becomes 1.88 equals h divided by 15. If you didn't get that, your calculator is probably in radian mode. And switch that or check your calculator manual if you're not sure how, or contact your instructor if you're really stuck. There should be a way to get it into degree mode so that tan 62 gives 1.88. If you're getting a different number, get it fixed or that's going to keep hounding you. Now, if we want to get h alone, right now it's divided by 15. The fix for that is multiply both sides by 15. On the right side, the 15s cancel, and we get 15 times 1.88, which is 28.2. 28.2 equals h. So this tree is 28.2 meters high. That's a pretty typical kind of application of SOHCAHTOA where you know some of the measurements of a triangle but not all of them, and one of these trig functions can help you. Your first decision usually is which of these three trig functions can I use given the information that I have. In this case it was opposite, adjacent, so we went to tan. Let's see a different one. What if we have, this is the ground, this is a wall, this is a ladder, and you know the ladder's 30 feet long because it says so on a sticker on the side of it, and this angle is 71 degrees. How far out from the wall is the bottom of the ladder? Think of yourself as standing down here on this angle that we know. Which sides are we talking about here? This is the adjacent side, which we are supposed to find. This 30 is the hypotenuse. And in this problem, we kind of don't care about the opposite side. That's how high the ladder reaches, which they aren't asking for. So adjacent and hypotenuse are our two today. Which trig function can help us with adjacent and hypotenuse? This one. Cosine is our friend today. We can write cosine 71. Please don't just write cosine or sine or tan. That doesn't mean anything by itself. It has to be the cosine of something. So cosine equals adjacent over hypotenuse, which for us means, I have to call this something, we'll call it x, over the hypotenuse is 30. Okay, well, cosine 71 is a number that a calculator can find for us. It looks like it's 0.325 or 0.326. 0.326 equals x divided by 30. If we want x alone, we have to multiply both sides by 30, so times 30 on that side, times 30 on that side, those 30s cancel, and we get 9.77 equals x. So this ladder is 9.77 feet out from the wall. Good. Let me show you one other type. This is not a ton of examples, but I hope this, if you've done this before, this might be enough to knock the rust off. And if it isn't, there's other practice to be found on the net. We'll get you sorted out. Another thing that can happen is sometimes it's the angle you don't know, and then things change a little bit. So, okay, here's a tower of some kind, and it's 150 meters high. And there's a cable that helps hold it up, which is 175 meters high, or long. And now the question is, what is this angle down here? Well, at first this isn't really any different. We still need to know what trig function can help us with this combination of sides. So if we're standing down here at this mystery angle, to us this is the opposite side, and this is the hypotenuse. So which trig function ties together opposite and hypotenuse? Looks like this one. Sine is the function of choice today. So we can write sine, I don't know the angle unfortunately, so I have to just go sine theta equals opposite over hypotenuse, so 150 over 175. All right, well, 150 over 175 is just a decimal. We can calculate that. 150 divided by 175 is 0.857. So now we have sine theta equals 0.857. Now, we want to find out what just theta is, which means that sine has to come off. Now, the way you do that, if this were a square, we'd square root it off. We need something that is the opposite of the sine function, and they do have that. It's called inverse sine or arc sine, and they usually write it like this, just sine minus 1. You do that to both sides of your equation. And just like squares and square roots cancel each other out, this sine and this inverse sine or arc sine cancel each other. And you're left with just theta equals inverse sine 0.857. On your calculator to do that, you probably press second sine or shift sine 0.857. And when I do that, I get that theta is 58.99 degrees. So basically, theta is 59 degrees. So you only use that shift function when you're trying to find an unknown angle. The rest of the time you're using normal sine, cosine, tangent when you're trying to find one of the sides. So get comfortable with that, and in another video will go over how this looks when we're doing vector analysis and components, which is the major way that we apply this in physics, especially in Unit 1 about momentum.